Hello guys, welcome back to my channel. So today we're going to continue the video series on OSPF. We had OSPF running in the previous video between R1 and R2, and particularly we were able to manipulate the election process. We had R2 being the designated router for this particular segment here, 192.168.0. We're going to add a few more routers, and also we're going to have to create point-to-point network types, and also we're going to have to create also the broadcast network types. We're going to create two types of network types here, and also we're going to make sure we're still in area 0. Okay, so OSPF runs in areas, and so we're going to create all this network in area 0. So I went ahead and added 3 routers. Okay, I added also a switch, because what I want to do is I want to convert this segment into a broadcast. It's going to be a broadcast segment. To see there's a switch here, which means all this interface of router 2, gig 00, gig 00 of router 4, and gig 00 of router 3, they're all going to be in the IP address subnet 192.168.2.0. So that makes it a broadcast segment. And also I created point-to-point networks between R3 and R5, and R4 and R5. So just bear in mind, in the working environment, these things are not done random. Okay, it depends on your needs. And let's say I don't want to have any other network in area 0 beyond router 5. So I could actually just create this link as a point-to-point network. That's my use case at the moment. And the same thing for router 4, between router 4 and router 5. I'm going to create a point-to-point network, and also we're going to see what's the purpose of this. As I told you in previous videos, the point-to-point network, they converge quickly, much quicker than the broadcast segments on broadcast segments. The reason is that there is no election. There's no election process happening on the point-to-point networks, and also we have less link state advertisements that are sent out on point-to-point networks. So right now I'm going to power on these devices, and also the IP naming IP address subnet scheme. This one is 192.168.2.0 because it's a that's a subnet I used for this one. But between R3 and R4, I'm using the subnet scheme 192.168.3.5, okay, which is between 3 and 5. Okay, same thing here for 5. All right, I'm going to power on these devices, and then also I'm going to make sure that that I made the initial configuration. And actually, as I said, whatever happened on this previous segment here is, unless we're going to enable OSPF here, you're going to see that it left its on the DR and BDR, okay, separate from what we saw on the previous segment. So each segment has its own rules in the OSPF. So let me power on these devices, and then we go try to start configuring them. So powered on all the routers and the switch, and now I'm going to configure the interfaces, and also after that I'm going to put them into OSPF. Just going to lower this one out. I'm going to start with router 2. So this is a diagram right here. Same diagram here. So router 2, I'm going to have to put 192.168.2.0 into gig 00. If I do show IP interface brief, I see we don't have any interface configured, any IP interface configured for gig 00. Okay, so I'm going to do that right now. Sure. The address is going to be 192.168.2.2. Okay, and then after that, all I need to do is to add that interface into OSPF. Okay, so I'm going to say router OSPF1. And one thing I didn't tell you is this network, how we're gonna have you see, like if you see router 3, router 4, and router 5, they're going to be called our border gateway routers. Why? Because we're going to have to add network in the future. We're going to add networks here so that other networks going to link here on route. This one are going to be border gateway routers with area 0, which is our backbone. So that's why I'm going to have to force R2 to be our root. Designated router for this segment. Okay, so this segment is a broadcast segment. I'm going to force R2 to be our designated router. Okay, so router OSPF, all I need to add here is network segment. Network is going to be 192.168.2.0. Then it's going to be 0.0.0.355 0. Okay. Okay, so what I'm going to do, since I want to force this router 2 to be the designated router, I'm going to shut down the OSPF process. Shut. And I'm going to configure this interface gig 00 to have a priority of 10. Okay, if we do right now, if I do show IP OSPF interface gig 00, you see it. That interface, okay, gig 00 has a priority of 1. I want to make it priority of 10. And the other ones are going to have default priorities. Okay, this interface is going to have the default priority of 1, and then 10 here. With that in place, since priority comes first in the election process, this router 2 is going to be forced to be the DR. Okay, so now I'm going to come here and say interface gig 00 IP OSPF priority 10. Okay. So priority is 10 here, and the OSPF is not running. Okay, if I go out of here, go IP OSPF enable, you'll see there's no enable. There's no enable because I shut down the OSPF process. So I'm going to do the same thing for R3 and R4. So basically what I do is I configure the interface and I enable OSPF. Go to interface, enable OSPF. Okay, and I'm going to come back and we enable the OSPF on the 3 routers at the same time. So on router 3, I configure the interface. I'm going to show IP interface brief. Okay, so router 3, I configure the gig 00. Okay, as the interface is out, and if I do show run interface, I also configure the loopback. Okay, to run interface loopback 0. Okay, I also made the loopback 0 interface point-to-point. Like I said in the previous video, our loopback interfaces are all going to be point-to-point. Okay, so that basically reduces the convergence time for OSPF. Okay, so I'm going to do the exact same thing for router 4. The router 4 router 4 interface configured. That will show IP interface brief. Okay, configure the interface and the loop back. And what I need to do right now is just enable OSPF on both router 3 and router 4. And I'm going to shut down the OSPF process so that it doesn't make any election for now. So I'm going to go to R3. I'm going to say OS process 1 and router ID. Router ID is for router 3 is going to be 0.0.0.3. Yeah. And the network that you have to advertise is network 3.0.0.0. Okay. And the wildcard mask is 0.255.255 area 0. Okay, so as I said before, why do we use the subnet mask, wildcard mask 0.255.255.255? Okay, why? Because we want to be able to change all these the octets, the bits in these octets, the 3 octets. But for the first octet, we don't want those bits to be changed. Okay, and the reason is because we have our loopback interface 3.3.3.3. Okay, we want that subnet, and we also have a router ID, okay, 0.0.0.3. So anyways, that's why we use that wildcard mask. And of course, there are other ways to provide more precise wildcard mask, but this is not the subject of our discussion right now. So yeah, so that's the OSPF is enabled on router 3. I'm going to just do shutdown. I'm going to have to add another network. So network I'm going to add is 192.168.2.0. And the wildcard mask is 0.0.0.255 area 0. Okay, and then I'm going to do shutdown. I'm going to do shutdown, and I'm going to leave it right here. Go to router 3, router 4, and do the exact same thing. Terminal, router OSPF process 1. OSPF process 1. Okay, router ID. The ID here is 4.4.4.4, and then network is 4.0.0.0, 0.0, and also we need to advertise the network that's connecting the broadcast, the physical interface network, okay, which is 192.168.2.0. okay. So for now, we're not going to be concerned with the point-to-point network linking to router 5. So that's the next page. So the wildcard mask here is going to be 0.0.0.255 area 0. Okay, so I'm going to do shut, and now we have router 3, router 4, and router 2. They are all configured, but the OSPF is shut down. Okay, so let me bring up 2. So, all right, router 2 is right here. So router 2, let me do terminal router OSPF 1. Okay, and I'm going to say so basically right now you see the we're ready to start the OSPF. Okay, OSPF on router 2, router 3, and router 4. So as I said in the previous video, if if I can enable OSPF on router 2, router 3, and router 4 within 40 seconds, then there's going to be a fair election. Okay, and if there's a fair election, then the router priority of router 2 should make it the DR. Why? Because I put router priority on router 2 to be 10. Okay, on the router 2 gig 00 interface, I put router to priority 10, as you see right here. And all the other ones I have by default 1. Okay, so what I'm going to do is I'm just going to do no shot. Okay, no shot on router 2, no shot on router 3, no shot on router 4. Okay, now we're going to wait. Let me just to show it. Oh, let's compare neighbor. Okay, so it's okay. So we have now the election has taken place. I was typing so slowly, and also the fact that to enable all the 3 routers at the same time. So now we have the status pool, which means the election has taken place. You can see it moved from 2-way to all the way to full, which means the election is done. So how do we know who is actually the DR and who is not the DR? Okay, I'm going to go out of here. I'm going to say show IP OSPF neighbor interface gig 00. Okay, so it tells me that this router 2 is a designated router, and the router ID is 0.0.0.2. Okay, and it has the priority of 10. The only reason why it became a DR because it has actually the lowest router ID. Okay, the highest router ID is router 4. Router 4 has 0.0.0.4, which is the highest router ID. In reality, if there was a tie on the priority, router 4 would have been the DR. But since we wanted to force router 2 to be the DR, we made the priority to be highest. So the router 2 is highest. And now, how about the other ones? Okay, what is the status of the other one? Let me just the configuration here. Let me save here. So okay, so it tells me that the backup designated router is router 4. Why is that? Because as we said, there's a fair election. So since there's a tie in the priority between router 3 and router 4. Okay, so now the second in line was the router ID. Highest router ID was router 4. That's why router 4 became the DR. Okay, now what's the status of router 3 or router 3 itself? Okay, let me just save this configuration. If I go into router 4 and I say show IP OSPF neighbor, I see the router 3 is designated as a DR order, which means it's just like any other router. It doesn't play any role. So if we have 3 routers. If we have 4 routers, we have 5, 6. All the other routers participating in the broadcast domain segment will all be named DR order. Okay, which means they don't basically participate. They participate, but they're not elected. Okay. So yeah, that's it for this particular segment. And the next segment is the point-to-point network segment. And before then, let me just take one more thing here. So I go into router 3 and I do show IP route. What do you get? Okay. So interestingly, we have something interesting here. Okay. we didn't set any default route. Okay, on router 3 we have a default route. Okay, where do we get that default route? We get the default route is the same default route that was forwarded from router 2 to router 1 to router 2. Now router 2 forwards that same default route to router 3, and we should also see that same default route on router 4. Okay, let's go to router 4. We'll go to router 4 to show IP route. Yeah, so we see this default route here. Okay, we didn't add any default route. That was forwarded, and OSPF external 2 type router route, which means it's a route coming from the internet. It means this router 4 to be able to go to internet. So if I do, which means technically if I do ping, let's say the Cloudflare IP address, DNS IP address 1.1.1.1, the ping should work. And how about if I'm pinging DNS, okay, like pinging google.com, google.com. Okay, ping doesn't work, and of course the only thing we need to add would be the IP domain lookup. So if I do terminal, I do IP domain lookup to ping google.com. Okay, so IP domain lookup is good, but one more thing I didn't mention is we have to tell the router 4 who on the internet is going to convert this google.com into an IP address. Okay, so our router is able to it's not able to resolve the URL, but it's able to query with that URL, which is already good. All we need to do is IP name server. You can give anyone, but I'm just going to give DNS. I'm going to give the Cloudflare DNS. Okay, I give this one IP name server. Okay, now after doing this, if I do ping, ping google.com, now it should go, right? So that's exactly the same thing. If you want to do the exact same thing, you can do on router 3. Okay, so yeah, so that's it for this particular I don't want to make this one very long. Next video we're going to do the point-to-point okay, we're going to do the point-to-point OSPF. We're going to activate point-to-point OSPF between R3 and R4, R4 and R5. Okay, so it's going to be point-to-point OSPF activation on those segments. So for now, I'm going to stop this video right now. I just don't want to make it too long. Okay, so talk to you in the next video.